In the last class, we completed force and laws of motion. I think all of you must have seen my last videos. Force is the basic cause of motion and which is related to momentum. So force is directly proportional to the rate of change of momentum according to Newton's second law of motion. According to Newton's second law, force is the product of mass and acceleration. That already we have discussed. Okay, but today's topic is impulse. So impulse, this is impulse. What is impulse? The product of force and time, the product of force and time, suppose you have to write definition, the product of force and time is known as impulse. Then what is impulsive force? That when large amount of force acts on a body for a small duration of time, that is known as impulsive force. At that time you will take the average force. So that impulsive force you can write formula, this one, impulse. Okay, so let us see the examples: hitting, kicking, jumping. Okay, so common examples: driving, firing a gun. These are the common example of impulsive force. Okay, but you know the units. So what are the units? SI unit. So Newton into second, dyne into second. So it is SI, this is CHSE. Then come to point, what it is as it is related with force, momentum. So what you are getting? You are getting, it is a vector quantity. It is a vector quantity. Which one? Impulse is a vector quantity because it has both magnitude and direction. Then come to point, what is its dimension? What is its dimension? So dimension is MLT minus 2, that is force, and time is equal to T. So now what you are getting? MLT inverse, which is equal to the momentum. तो इसका मतलब impulsive force का जो dimension है, momentum का dimension वही है. Okay? So dimension of momentum is equal to the impulsive force. Clear? Then come to point. Most important tendency or properties. Impulsive force does not remain constant. It changes from minimum to maximum or zero to maximum or vice versa. Maximum to minimum, minimum to maximum. That means, so it is whatever it is 0 to maximum, then from maximum to 0. That's why we write according to Newton's second law, we can write mathematical expression. Mathematical expression F is equal to how much according to Newton's second law? dp by dt. According to Newton's second law, Newton's second law of motion. Now what you are getting? dp is equal to f dt. Equation 2, equation देते रहना. Now integrating that value within the limits, if you integrate this one, suppose P1 to P2, it is, who can say that is C 0 to force. Your impulsive force is the product of force and time. It remains, does not remain constant. 0 to maximum or maximum to 0. So it is 0 to T. So now what will, it is constant value. If we take this one is dp का integration कितना p, upper limit p2, this one is lower limit, so p2 minus p1 is equal to f constant बाहर लाए, dt का integration t, 0 to t upper limit t, lower limit 0, t minus 0 t, so it is t. So it is Ft. You are getting this one. So you will get this one. Now Ft is equal to P2 minus P1. Okay, and this force is average force. So change in momentum is equal to the impulsive force. Change in momentum is equal to impulsive force. You can write this one in vector form. It is the vector form. Okay, so if you can write this one now, from using second law, you will get P2 minus P1, you can say it is dP. So dP by dt is equal to force. वो मिल गया फिर न्यूटन सेकंड लॉ. सो इम्पल्सिव फोर्स, ये जो फोर्स इम्पल्सिव फोर्स मिला, ये किसका साथ बराबर है? चेंज इन मोमेंटम का साथ. तो मोमेंटम का जो यूनिट डायमेंशन जो है, इम्पल्सिव फोर्स का डायमेंशन यूनिट वही है. तो व्हाट आर द common examples that I have already told you. Okay, what are the common examples? A cricket player while catching the cricket ball takes his hands, lower takes his hands, पीछे ले जाता है his hands. Okay, lowers his hands. Then when a person falls from a certain height on a cemented floor, then china and glasswares are wrapped in paper of straw pieces. The vehicles like scooters, car, bus, truck, etc. are provided with suckers, and buggies of a train are provided with the buffers. It is difficult to catch a cricket ball than to catch a tennis ball. In a head-on collision, it also happens. An athlete is advised to come to stop slowly. ये जितना एग्जाम्पल दिए, ये 8 एग्जाम्पल में आंसर एक ही है. क्या है? If time of impact increases, you have to apply less force. If there is less force, there is less change in momentum. There is no injury, or you will feel less pain. Okay, to prevent that one, and one I am giving completely explanation. Suppose one is you see a cricket player lowers his hands while catching the cricket ball. Suppose you are catching the cricket ball in this manner. cricket ball mass m, velocity v, तो momentum m भी हुआ. आप ऐसे पकड़े तो टाइम ऑफ इम्पैक्ट ज्यादा हो गया, तो लार्ज चेंज इन मोमेंटम हुआ. लग जाएगा तो ये पूरा खराब हो जाएगा. ऐसे भी आपका बहुत प्रॉब्लम, इंजरी हो सकता है. लेकिन जैसे आप हाथ तुरंत लिए तो उसका टाइम ऑफ जो कांटेक्ट था वो धीरे धीरे बढ़ गया. तो टू रिड्यूस द मोमेंटम ऑफ बॉल आप धीरे धीरे कम होने का, डिक्रीज होने के लिए ले रहा है. तो इंपल्स क्या हुआ ना, फोर्स इनटू टाइम एंड चेंज इन मोमेंटम. सो इट हेल्प्स the cricketer to apply less force against the ball in order to stop it. So the ball in turn exerts a smaller force on his hands, thus the hands are not injured. Okay, in every case same thing you have to apply. और एक बात बता रहा है, जैसे हम लोग ग्लास, शीशा, काचो शीशा को पैक करते हैं. क्यों पैक करते हैं? जैसे आपका ऐसे होगा, टाइम ऑफ इम्पैक्ट ज़्यादा हो जाएगा, तो ज़्यादा है तो फोर्स कम हो जाएगा, तो उस टाइम तक पहुंच जाएगा. तो टाइम ऑफ इम्पैक्ट बढ़ गया, फोर्स कम लगा, तो चेंज इन मोमेंटम 0 हो गया, तो आपका कुछ नुकसान नहीं होता है. तो बहुत जिनसे जो पैक करने के लिए जाते हैं, सिंपल लाइट चीज़, ग्लास जैसा, चाइना वायर, वो सब जैसे शंख चीज़, जो चाइना वायर समझ रहा है, बाथरूम मटेरियल्स जो होता है वो सब चीज़ तो यूज करते, तो उसको पैक करने के लिए ये चीज लगा जाता है. तो कुछ नहीं आता है तो क्या बोलेंगे ना, इट इज ड्यू टू इंपल्सिव फोर्स टू प्रिवेंट फ्रॉम दैट मटेरियल्स और टू प्रिवेंट फ्रॉम दैट वेलोसिटी ऑफ द बॉल. वी आर अप्लाइंग दिस वन. एंड अनदर वन इज इन फिगर. हाउ कैन यू अप्लाई दिस वन? लेट अस सी. सपोज आप जो मच्छरदानी लगाते हैं, कांटे का एग्जाम्पल बताए थे, है ना, हैमर यूज करते हो, पीटते पीटते लग गया हाथ में, तो क्या होता है, बहुत दर्द होता है। क्यों ना, लार्ज फोर्स, आप जोर से पीट रहे हैं, जोर से पीट रहे, तुरंत लग गया, तो बहुत फोर्स लगा लेकिन तुरंत लगा, बहुत फोर्स और सडन लगा, तो इसलिए हम लोग को ज्यादा चोट लगता है। वन थिंग इज रिमेंबर दिस वन, सपोज देयर आर टू फोर्सेस, है ना, two forces and that acting in this manner. So one is, suppose force one is in this manner, this is x axis, ये भींग गया है हमको लग रहा है, ये x axis, this one is y axis, so this one is f1, suppose this is in f1 time, because impulse is product of force and time, so force first case. Second case and another case, suppose this is the case 1 and another case you are applying this one, suppose this is f2, it is t2, okay, x axis, y axis, origin, you listen this one. So what you are applying, this is average force, this is the time, this is the average force. What you are getting, you are getting f1 into, you are getting f1 into t1 is equal to f2 into t2, okay. So what you are observing, actually we note that, okay, the force f1 for curve is greater than the force f2 the curve b. So from the graph we note that the force f1 for curve A, it is curve A, it is curve B, is greater than the force F2 curve. F1 curve greater than हो रहा है F2 curve. So time to T2 for which force F2 acts is greater in case of B, then the time T1 in case of curve 1. So that's why you are writing they are inversely proportional, inversely proportional, okay. जैसे हुआ, कैसे हुआ, F1 by F2 देखो is equal to T2 by T1 हुआ, तो फर्स्ट केस का जो कर्व था वो टाइम इंटरवल का साथ सेकंड टाइम का साथ डायरेक्टली प्रोपोर्शनल, मतलब ये इसका साथ, ये इसका साथ हो रहा है. सो इट इज ऑब्जर्व दैट a given change in linear momentum can be produced by applying large force for a smaller time. पहले समझो, जहाँ लार्ज फोर्स है, लार्ज फोर्स हुआ वहाँ कम टाइम, मतलब आप बोलते हो बहुत बड़ा धक्का हुआ, एक्सीडेंट हुआ, वो उस टाइम में वो ज़्यादा जोर से चलाया था, ज़्यादा जोर से चलाया था, बहुत तुरंत एक्सीडेंट जो हुआ उसको बहुत नुकसान हुआ, स्पॉट डेथ हुआ, खिनबिन हो गया, दीवार टूट गया, व कुछ चेयर बेंच जो भी जहाँ एक्सीडेंट हुआ वो कुछ भी हो सकता है. बट reverse case, if you are applying smaller force there for larger time, so this is known as impulse momentum theorem. As impulse is directly related with momentum and this is happening due to F1 into T1 is equal to F2 T2, this is known as impulse momentum theorem, okay. And we have to solve numericals applying this one. Just I am giving one. A hammer of mass 1 kg moving with a speed 6 meter per second. Suppose this is the question. Let us solve some numericals based on the impulse. What is the question? A hammer of mass 1 kg. So numerical, hammer of mass 1 kg, it is given. First read the question, same process, mass is 1 kg moving with a speed of 6 meter per second, okay, strikes a wall and comes to rest in 0.1 second. That means V is equal to, it is U, V is equal to 0, so that is V is equal to 0, U is equal to 6 meter per second. स्ट्राइक से वॉल वहाँ लगा, फिर आ गया, कम्स टू रेस्ट, मतलब V हो गया 0, T हो गया 0.1 सेकेंड. क्वेश्चन, कैलकुलेट द इम्पल्स फोर्स. इम्पल्स फोर्स कितना हो गया, कैलकुलेट, क्वेश्चन कैलकुलेट द इम्पल्स फोर्स, डाटा इज दिस मच, द रिटार्डेशन ऑफ द हैमर, द रिटार्डिंग फोर्स दैट स्टॉप द हैमर. एज पर द क्वेश्चन वी हैव टू कैलकुलेट इम्पल्स फोर्स. इम्पल्स फोर्स I is equal to F into T. So F कितना हुआ, M dp by dt, M V minus U by T. इंटू टी, ए कट गया टी टी, तो m कितना हुआ 1, v कितना हुआ 0, c कितना हुआ 6, ये t कट गया तो इतना कितना है इम्पल्स कितना हुआ -6 Newton into second, that is impulse force. Then retarding force that stops the hammer, that is retarding force stops the hammer to dp by dt, that means ft force already f into t by t, so that means you are getting the same cheese. Okay, so that one is, so that was 6 by, it is already given, and 0.1, so that means 60 Newton. This is the 60 Newton. You are getting the 60 Newton, or you can say it is 60 Newton. Okay, then another bit is the retarding force that stops the retardation is how much? A is equal to retardation f by m, the opposite of acceleration. The velocity decreases with respect to time, that is known as retardation. F is equal to a, f is how much? 60, m is equal to 1, so that is 60 meter per second square. In this way we have to solve some numericals. After reading theory you have to write the derivation, how it is coming, what is the formula, based upon the formula at least solve 2 numericals, then increase your ability, our consistency. आप रेगुलरिटी रहो, सिंसियरिटी दो रेगुलरिटी एवरीडे करोगे ना, तो आपको जो डिफिकल्ट है वो धीरे धीरे इजी लगेगा और आपको फिजिक्स बहुत अच्छा लगेगा. थैंक यू, हैव ए गुड डे.